In grade 10 and 11, linear number patterns were introduced. The general formula for a linear number pattern was derived by drawing up a table, as illustrated. The general term for the linear sequence, 13, 6, -1, -8, etc., is given by Tn equals -7n plus 20. In grade 12, we will be using a formula that describes the general term of a linear sequence, also called an arithmetic sequence, which is given by Tn equals a plus d times n minus 1.
Tn is the nth term. A is the first term of the sequence. D is the common difference between successive terms of the sequence. And n represents the number of terms contained in the sequence. Looking at the same linear sequence, the difference between successive terms is -7. Thus, Tn equals 13 minus 7 times n minus 1. Simplifying that gives us Tn equals -7n plus 20, which is the same formula obtained when drawing up the table.
When n equals 1, we get the first term of a sequence. The first term of a linear sequence is therefore a. When n equals 2, we get the second term of the sequence. The second term of a linear sequence is therefore a plus d. And when n equals 3, we get the third term of the sequence. The third term of a linear sequence is therefore a plus 2d. The first four terms of a linear sequence are a plus d, a plus 2d, and a plus 3d. The difference between successive terms of a linear sequence equals d, which we can illustrate by determining the difference between successive terms of a general linear sequence. The common difference between successive terms is therefore given by t2 minus t1, t3 minus t2, t4 minus t3, etc. Given the arithmetic sequence 20, 23, 26, 29, etc., determine how many terms the sequence contains, and the value of the 25th term. The difference between successive terms is plus 3. The first term, 20, is the value of a. D is 3, n is what we are looking for, and Tn equals 101. Tn is the value of the nth term, which in this case, is the last term, 101. Substituting these values into the general formula for the nth term, we get n equals 28. This sequence therefore contains 28 terms. To determine the value of the 25th term, substitute the value a, d, and n, which is 25, into the general formula for the nth term. The value of the 25th term is therefore 92.
Given the arithmetic sequence, -5, x, y, 7, etc. Determine the value of x and y, the general formula for this sequence, and which term will have a value of 235.
All we know about this sequence is that it is arithmetic, which means that the difference between successive terms is the same. So, x minus 5 equals y minus x equals 7 minus y. We can now formulate an equation. X plus 5 equals y minus x. Isolating y gives us y equals 2x plus 5. Likewise, y minus x equals 7 minus y. And isolating x, we get x equals 2y minus 7. Solving these simultaneous equations gives us y equals 3, and x equals -1. The sequence is therefore -5, -1, 3, 7, etc. Before we can determine the general formula for this sequence, we need to know the common difference between successive terms, which is +4. Substituting a and d into the general formula for an arithmetic sequence, we get Tn equals 4n minus 9. Finally, to determine which term of the sequence has a value of 235, substitute 235 for Tn into the general formula for the nth term. N equals 61, which means that the 61st term of this sequence will have a value of 235. The fourth term of an arithmetic sequence is 28, and the 10th term is 10. Determine the value of the 51st term. The fourth term of the sequence is when n equals 4. Therefore, T4 equals a plus 3d. The value of the fourth term is 28, so 28 equals a plus 3d. Isolating a, we get a equals 28 minus 3d. Likewise, the 10th term of the sequence equals a plus 9d. The value of the 10th term is 10, so 10 equals a plus 9d, which means a equals 10 minus 9d. We now have simultaneous equations involving the variables a and d. Thus, 28 minus 3d equals 10 minus 9d. Solving for d, we get d equals minus 3. Substituting this value for d into either of the two equations gives us a equals 37. The first four terms of this arithmetic sequence are therefore 37, 34, 31, and 28. The 51st term of this sequence is when n equals 51. Thus, t51 equals a plus 50d. And since d equals minus 3, the 51st term of the sequence will have a value of minus 113. Determine the smallest positive term of the sequence, minus 133, minus 129, minus 125, etc. Before we begin, notice that the first term is a negative number, minus 133, and each successive term thereafter is more positive than the previous term. The common difference of this sequence is plus 4. This question is asking us to determine the first positive term of the sequence. Now, because it isn't very practical to continue adding 4 to each term, until we get the first positive number, we will determine the general term of the sequence. The general term, Tn, of this sequence, is given by 4n minus 137. Depending on the value of n, Tn will have a certain value. And since we want to know which term of the sequence is the first positive number, we are therefore looking for the value of n, where Tn is greater than 0. Therefore, we need to solve the inequality, 4n minus 137 is greater than 0. The solution to this inequality is, n is greater than 34.25. Now, n, which is the number of terms of a sequence, is a natural number. So the very first natural number after 34.25 is 35. In other words, the first term of this sequence which is greater than 0, is the 35th term. We can verify this by determining the value of the 35th term, which is 3, and then determine the value of the preceding term, the 34th term, which is minus 1.